right, so today we're going to do some regression practice. Our goal for today is I can write a regression equation and use it to predict values. Go ahead and rate yourself with a 1, 2, or 3. All right, so basically what we're going to be doing today is we're going to be given a bunch of data. Okay, so we were given a bunch of data in our correlation coefficient activity, and we had to draw a line of best fit, right? So what we're going to do is we're going to use Desmos software to help us predict the actual line of best fit. Okay, and that's going to be our regression equation. All right, so let's go ahead and get started. It says, in BMX dirt bike racing, jumping high or getting air depends on many factors. The rider's skill, the angle of the jump, and the speed and weight of the bike. For a given ramp, the table shows data about the weight of a dirt bike compared to the maximum jump height that was achieved. So if you look to the right here, it's saying a 19-pound bike, the height in inches that the bike was able to jump was 10.35 inches, and then so on and so forth, right? So the first thing says, number 1, in Desmos, create a table of the data in entry 1. So you're going to have to open up Desmos. I'm going to split screen with it over here so that we can see what I'm doing as I go. Okay. And it says create a table. Okay, so what you're going to do is you're going to click in that box that's highlighted right now. It's easier to see this one. Oops, mine went away. It's easier to see this when I have a full screen, but hey. I just accidentally hit the wrong button. So what you're going to do next is you're going to hit the add button. The add button is the little plus sign right there on the left. And it's going to say, what do you want to add? Do you want to add an expression, a note, a table, a folder, an image? We're going to add a table. Okay, so we're going to click table. So now here you can enter Y1 and Y2 values. So I'm going to start by putting in 19, and I'm going to hit enter. Okay, enter is this blue button at the bottom right hand there. I'm going to hit 19.5, blue button, and then it's going to start to predict the next numbers. Just be careful because it's not going to give me everything that I need. Or it's going to it's not going to match it perfectly. So 20 I do need next, 20.5 I do after that. I do need 21 after that, but then I don't need 21.5. I need 22 next, and then I need 22.5, and then 23, 23.5, and 24. Okay. I'm going to go over to Y1. There should be no prediction. There could be a little bit of prediction here, but then just be careful, okay, that it's typing what you actually need to type. So 1035, like the table itself will predict what's next. 10.3, 10.25. So it's not predicting any of my Y values, which is good. 10.2, 10.1, 9.85, 9.8, 9.79, 9.7, and 9.6. Okay, so there's my table. So number 1 in Desmos, create a table for the data entry. And then in entry 2 of your Desmos file, type the equation y1, and then that is approximately mx1 plus b. Okay, so this is in entry 2 because we already did entry 1. So in entry 2, we're going to hit y1, right? So we're going to do y1. And then you're not going to use equals. You're going to use approximately. So you may have to go to ABC here to find it. You do. And right 2 to the left of the enter is approximately. And then I need M X1 and then plus B. So plus sign and then the B like that. Okay. So what's going to happen, if you notice, this is in the form y equals mx plus b, but we're not putting equals because it doesn't have to go through all the points that I just graphed, right? Like we're getting a line of best fit. We want it to go through as many as possible. So that's why the approximately is there. What's going to give us? It's going to give us an r squared value, an r value. If you scroll down a little bit, you can see the m value and you can see the b value. So we're going to write those things down. So it says Desmos will determine the parameters for M and B that are the best fit line for your data. So we're going to say M is negative 0.156 and B is 13.348. Okay, so now it says write the equation of the regression line. So it's in the form y equals mx plus b. So I'm going to do y equals m, which was negative 0.156, x, and then plus b, which was 13.348. And that's my regression line. So let me, it's hard to see it when let's just get rid of my notes for just a second so you can see this. So if you go back to your data here, you can see all my points on the data right there. You see how the line of best fit doesn't go through all of them perfectly, but pretty good. So what I just did is we wrote the equation, or Desmos did it for us. It wrote us the equation of that line right there. Okay. All right, so now what it's going to ask us in notes is it says, is there a positive, negative, or no correlation between bike weight and jump height? How do you know? So is it positive, negative, or no relation? So I can tell this just by looking at what's on my paper, but let's go back to Desmos just in case right there. What do you think? I think it'd be negative, right? Because that's a negative sloped line. So there is a negative correlation. So let's go back and say that there's a negative correlation. Okay. How do you know? How do we know? Because the slope is negative. Next question. How strong is the correlation between the two variables? So to see how strong the correlation between the two variables is, we want to use the correlation coefficient. Remember, the correlation coefficient is the R value. And you might have heard me say, and it gives me an R value. So if you look back over here, it says that R is negative 0.9912. So make sure you're not using R squared. Make sure you're using R. You can see that it's negative 0.9912. Go back here. So how strong is the correlation between the two? There is a strong negative correlation. How do I know? So I'm just going to continue the sentence. I'm going to say, because the correlation coefficient, or I can say the R value. I'm going to be proper here and say the correlation coefficient is negative 0.9912, which is very close to 1. Sorry, very close to negative 1. All right, lots of questions in that one, but I made sure I answered them all. Okay, the next one says, what does the rate of change, which is the slope, remember, of your equation mean in real world units? Okay, so let's go look back and see what that slope was. It was negative 0.156. Okay, so what I like to do is I like to write down the slope. This is a nice little trick here. I like to write down the slope, negative 0.156. I like to always put it over 1 if it's not a fraction yet. Then I like to go look and see what y is. It's inches. X is pounds. So this is inches, and this is per pound. Okay. So I want to write a sentence now. Remember, this is a rate of change, and it's not exactly what the rate of change is. It's on average. So I like to start off my sentence with on average, comma. Remember, we're talking about BMX bikes here. I'm going to say the height a bike reaches decreases by 0.156 inches for every pound it weighs. Okay? So on average, the height a bike can jump decreases by 0.156 inches for every pound it weighs. For every I'm going to put extra pound it weighs. Okay. All right, what does the initial point, the y-intercept of your equation, mean in real world units? So I'm going to write down what the initial value was. That's 0, 13.348. That's my y-intercept. What does the y-intercept of your equation mean? So that means 0, remember, is pounds. The x value is pounds, I meant. And the y value is the height in inches. So I'm going to say, it is saying that if the bike weighed 0 pounds, if a bike weighs 0 pounds, then it would get to a height of 13.348 inches. Okay. Now, number 6 says, does your answer to number 6 make sense? Why or why not? So hopefully, as I was saying out loud, you were like, huh, what? That doesn't make any sense, because it doesn't. It's impossible. A bike can't weigh 0 pounds. A bike can't weigh 0 pounds. Okay? It wouldn't exist then, right? All right, 7 says use your equation to predict the maximum height for a bike that weighs 21.5 pounds. So the first thing you want to do is you want to say, I gave you a value. Did I give you an X value or a Y value? 21.5 pounds is an X value. So I gave you an X value. You want to find a Y value. So we're going to use the equation Y equals, and it was negative 0.156x plus 13.348. And we are going to plug in that X value, right? Because this was an X value. So we have Y equals negative 0.156 times 21.5 plus 13.348. I can go ahead and put that in my calculator. And I get Y equals, and we're going to round to 3 decimal places. So 3 decimal places. 9.994 inches. That's my answer. Okay, so please keep in mind I can give you an X value or a Y value, and you can solve for an X value or a Y value based on that. Okay, this next one here is very similar, except for we don't have to put all of the information in Desmos because it's already put in Desmos for us. The same thing's going to happen on your test. All the information will already be put in Desmos for us. I took a screenshot of it, and you can look at it. Because if you mess up putting it in Desmos, it's going to mess everything up. Okay, so here's this one. It says, in baseball, do the teams with a lot of money have the best players? The table shows data about how much money a team spends on players compared to how many wins that team had in the year 2012. The information is given as a scatter plot, and the regression information is provided below. Okay, so the x-axis, I'm going to put it up here. X-axis is payroll in millions. Y is the number of wins. Okay, so if you look at it, this was all put into Desmos already, and this is what popped out here, this graph. And this is also what popped out. Okay, so y equals mx plus b. We got the r value right here. Make sure you're looking at the r value. And then we got m and b right here. Okay, so it says use the information above to write the regression equation. So we're going to write y equals, our m value is negative 0.019398 x plus b, 92.017. Okay, what does the m value represent in the context of the problem? Okay, so once again, I like to say, all right, that's that negative 0.019398. I'll put it over 1. I'm going to say what the y value is because it's rise over run. Y is wins. X is payroll in millions, so $1 million. $1 million. I'll write it like that. Okay, millions made. So I'm going to say on average, a team will go down 0.019398 wins for every $1 million made. On average, a team will go down 0.019398. Notice I'm not putting negative because the word down is implying that. Wins for every $1 million made. For every $1 million made. Okay? Next, use the equation to predict the number of wins for a team with a $125 million payroll. So first off, let's switch my highlighter color here. I'm going to do it in purple. $125 million. Is that an X value or a Y value? Millions. It's an X value. So I'll put X up here. And now I know that I'm going to plug that in for X. So I'm going to do Y equals negative 0.019398 times my X value, which is 125. And then plus 92.017. All right, now I'm going to throw that into my calculator. Be very careful. Don't forget the negative, and don't forget 0.019398. And you will get Y equals 89.59225. That's what my calculator said. So let's make sure we're adjusting this properly. It says use the equation to predict the number of wins. So remember, when a win is a whole number, right? So I'm going to predict that there will be, so I have to decide if I'm going to say 89 or 90 wins, right? If you round properly, you're going to say 90 wins. But if you think about it, they didn't quite get 90 wins. So I'll take 89 wins also. Okay, I'll take either one because it's not quite 90. They would need a little bit more money to get 90 wins. Overall, how strong is the relationship between the money spent on the players and the number of wins? So we're going to look at the correlation coefficient. It is negative 0.141. So it is not strong. I would say it's pretty weak, if anything. Correlation coefficient is negative 0.141, which is pretty close to 0. So that means there's hardly any correlation at all whatsoever, okay? So go ahead and re-rate yourself. I can write a regression equation. Are you okay with, given the data, given the Desmos output, are you able to write an equation from there and then answer questions about correlation, slope, things like that? All right, that's it for regression practice. We will start working on parallel and perpendicular lines next.